number 30. So this question, in the region of the first quadrant enclosed by the coordinate axis, the line x equals pi and the curve y equals cosine of cosine x is rotated about the x-axis. What is the volume of the solid generated? Okay, so we've got our bounds from 0 to pi by the it's bounded by the coordinate axis, and it's some function that I don't even know what it looks like, but it really doesn't matter because the question is, the curve is rotated about the x-axis. What is the volume of the solid generated? Okay, this is clearly just, it's rotating about the x-axis, so it's just the disk method. And so what is our integral? Well, it's pi r squared from 0 to pi dx, where r is going to be equal to our function, which is cosine of x, right? So all you have to do is just plug that in, and we get pi from 0 to pi of the cosine of x, all of that squared dx. And I would recommend plugging into your calculator just like that. In parentheses, cosine of, in parentheses, cosine of x, close parentheses, square. That's your best bet. I mean, that's really the only way to do it. So you're going to take this integral in your calculator and then multiply it by pi. So it's as simple as that. So we do pi, the result of this integral is about 1.9225, it looks like. And then when I multiply that by pi, I get 6.040, which is C, which is my answer. Okay, so just to recap, the point is you've got some function, you're rotating about the x-axis, they give you the bounds from 0 to pi, and so you just do the disk method. That's all you got to do, and for the disk method you just find the volume by doing pi r squared, where r is your function, and so you just plug that into your calculator, you integrate it, multiply it by pi, and you've got your answer. Hope you understood it. See you in the next video.